When an AC voltage is produced, the voltage switches polarity over time. When graphed over time, the wave traced by this voltage of alternating polarity takes on a shape known as the sine wave. Here are some characteristics of the sine wave. The instantaneous value is the magnitude of a waveform at any particular time. The peak amplitude is the maximum value of the waveform as measured from its average value. The period is the total time it takes for the wave to make one full revolution. It is the reciprocal of the frequency of the waveform, and vice versa. The RMS value is the equivalent DC power of the AC sine wave. We can find this by 0.7071 times Vm. The peak value is the maximum instantaneous value of a function measured from 0 volts. The peak-to-peak value is the difference in voltage across peaks of the wave. In other words, the sum of the magnitude of the positive and negative peaks. An example of AC sine wave production is the AC generator. As an AC generator rotates due to an energy source, an AC sine wave is induced, as seen in this example. The polarity and current direction of a sine wave is indicated by it being either in the positive or negative quadrant at a particular time, as seen in the following graph. The following equation is used to describe the sine wave. If the phase is positive, the wave lags and is therefore shifted to the left. If the phase is negative, the wave leads and is therefore shifted right. Here's an example in which we determine the characteristics of a sine wave from a graph. To determine the peak amplitude, we look at the distance in the y direction, from the crest of the graph to the average value, which is 0 in this case. We then times this by the volts per division. To determine the period, we look at the distance between the crests of the graphs in the x direction, and times this by the time per division. To calculate the frequency, we sub the period into the formula frequency equals 1 divided by period. Thanks for watching.